So let's now talk about solving trigonometric equations using a graphing calculator. All right. The problem says use a graphing utility to find the solutions in the interval 0 to 2 pi. All right. So notice we're only looking for a set number of solutions, 0 being included in this interval, 2 pi not being included. And we want to round solutions to 3 decimal places. So yes, our calculator can be used to find solutions to trig equations. The only thing we don't love about it is that it gives us decimal approximations as opposed to exact answers like we get when we are able to use our unit circle. All right, so here's an equation. We have 4 sine cubed x plus 2 sine squared x minus 2 sine x is equal to 1. Well, the best way to solve equations using your calculator is to set the equation equal to 0, then graph the function, and your zeros will correspond to the x-intercepts, okay? All right, so we are going to begin by setting the equation equal to 0. We subtract 1 from both sides of the equation, giving us 4 sine cubed x plus 2 sine squared x minus 2 sine x is minus 1 equals 0. The solutions to this equation will be the x-intercepts, or the zeros of the graph. So what we want to do now is graph the function and use the calc 0 feature, all right, of your TI-84 to find the x-intercepts on the interval 0 to 2 pi. Now, when you go to plug this into your calculator, all right, it's going to look a little bit different than the equation that we have here. Notice, to write sine cubed x, we go into, again, we're graphing this, so we want to go to y equals, and we're going to type in 4 sine of x. We close out sine of x and then put the exponent on the outside, right? That is sine cubed x. Plus 2 sine x, close our parentheses, power goes on the outside, squared, minus 2 sine x, close parentheses, minus 1. This is the function that we want to graph. Whenever you are graphing trig functions, make sure your calculator must be in radian mode, right? Make sure you are in the correct mode when graphing trig functions. Remember, it might be in degree mode from the last time you were working with triangles, so just double check that. And graphing your function in your standard window will give you an image that looks like this. Now, we're only looking to find solutions that are between 0 and 2 pi. So it's a good idea to play around a little bit with our window. So I want everybody to hit the window button on your calculator. And notice, I have changed our x minimum value to negative 0.5, right? 0 could potentially be a solution, so I want to show a little bit of room to the left of 0. A little bit to the left of 0 would be 0.5. And my x maximum, well, you can actually just plug in 2 pi, right? Because that would be the greatest value, and we're not going to include 2 pi in our solution set. I have also made changes to the y min and the y max. Here I have y min of negative 2 and a y max of 4. So we set that window up in our calculator, we hit enter, and we get a little bit better idea of what's happening with our graph. All right, this is our x interval that we're looking at, and it looks like we're going to have a few different x-intercepts. One thing to make note of in this problem is right around these areas here. It's actually a little bit tough to tell what's happening. We can get a better idea of what's happening near the x-axis by changing our window again. So I want you to hit window one more time, and we're going to change our y scaling. Notice my x scaling, this is still 2 pi here. All right, it'll automatically dump in that decimal for you. But let's make y min negative 1, and let's make y max 1. Because again, we're trying to figure out what's happening really, really close to that x-axis. Find where it crosses the x-axis. And we hit enter again and go to our graph. And here we can see now that, yeah, our graph actually crosses through the x-axis at these little x-intercepts. And so we're looking for now all the x-intercepts on the interval from 0 to 2 pi. We have 1, 2, 3, 4, 5, 6 solutions that we need to find. And we can do that by hitting second trace or second calc on your calculator and selecting 0. All right, your calculator is going to prompt you to choose a point that is to the left of a 0 and then to the right of a 0. You will hit enter after both of those. Hit enter one more time, and it will spit out the decimal approximation. Now, you are going to have to do this 6 times, all right? Once for every single x-intercept, where you choose a left-bound point and a right-bound point of each one of the zeros. Okay, if you have any questions on that, make sure you reach out for help. You should have found zeros using your calculator earlier in the year and in your Algebra 2 classes as well. If not, don't be afraid, ask for help. We get our 6 solutions. X is equal to 0.785, 2.356, 3.665, 3.927, 5.498, and 5.760. All right, so there are 6 solutions corresponding to our 6 x-intercepts, or zeros, between 0 and 2 pi. Let's try another one. Use a graphing utility to find the solutions in the interval 0 to 2 pi. Round your solutions to 3 decimal places. Here we have cosine x times cotangent x, all divided by 1 minus sine x is equal to 3. Well, again, whenever we're solving using a calculator, the easiest way to do it is to set the equation equal to 0, because then the solutions will be the x-intercepts. So we subtract 3 from both sides of the equation. Now, the challenge here is that our calculator doesn't actually have a cotangent button, all right? That means if I want to plug this into my calculator, I have to rewrite the expression in terms of sines, cosines, and tangents. Well, instead of multiplying by cotangent, I can actually use the reciprocal identity of cotangent. The reciprocal of cotangent is tangent, so instead of multiplying by cotangent, let's multiply by its reciprocal, 1 over tangent of x. And so that actually throws a tangent of x into the denominator of our fraction, leaving us with cosine of x divided by the quantity tangent of x times the quantity 1 minus sine x. Notice the parentheses here around 1 minus sine x. Minus 3 is equal to 0. And at this point, we can begin to go ahead and plug this into our calculator and graph our function. All right, you could have other options here, would have been to rewrite everything in terms of sines and cosines. We could try to combine some stuff to make it even more simple if we wanted to. But the great part about a calculator is if we know how to plug into our calculator, it can do some pretty difficult calculations without us having to simplify. So we are going to graph the function and use the calc 0 feature to find the x-intercepts on the interval 0 to 2 pi. So we go to y equals, and we type in cosine x divided by, and we need to be very, very careful. We need parentheses around our entire denominator. So that becomes a parentheses, tangent of x, I close out my parentheses there, parentheses 1 minus sine x, close parentheses, that closes out this grouping here, and one more parentheses will close out everything in the denominator. And after that, we type in minus 3. Okay? All right, so we need to put the whole denominator inside of parentheses there. We graph that. Make sure your calculator is in radian mode. Again, whenever you're graphing trig functions, we must be in radian mode. And you should get a graph that looks like this. Now, again, this is our standard 10 by 10 window. If you hit zoom 6 on your TI-84, it will get you to your standard window. Well, again, we're only looking for the solutions between 0 and 2 pi. So hit the window button on your calculator, and let's make some changes to our window. X min, let's plug in negative 0.5, right? I want to be able to see if 0 is going to be a solution. So I want to go a little bit to the left of 0. Negative 0.5 is a number that's a little bit less than 0. And X max, we can plug in 2 pi, all right? 2 pi is not included on the interval. So that's going to be the farthest right that we're really going to be looking for solutions. And y max, y min, I've decided to put in y minimum of negative 2 and a y max of 2. Again, you could choose a couple different options there, but we're looking for values around the x-axis, right? Because we want to find those x-intercepts. So doing so leaves us with an image that looks like this. And this is nice. We get a nice clear view that there are 2 x-intercepts. We can then hit second calc 0, find the zeros at each location. Again, we're going to have to do that process twice, once for each one of the zeros, and we get our zeros of our equation. X is equal to 0.524, and x is equal to 2.618. All right, so that is using your calculator to solve trigonometric equations. Again, if you have any questions on finding zeros using your TI-84, make sure you reach out for help. I'm happy to give you advice on how to do that.